Hello, honored algebra students. Mr. Lawrence here, and because Miss Lissa Dulek sent me an email, I made a video just for her. All right, first of all, she wanted to remember standard form, domain, range, and functions. All right, let's go standard form first. Remember, standard form is ax plus by equals c, and often we want a, b, and c to be integer coefficients, right? Okay, so we've got to get x and y on the same side. So I think I'm going to go 2x, subtract 2x from both sides here on this red equation. I'll get negative 2x plus 3y equals 5. But I'm not in standard form because remember that a must be greater than 0. So I'm going to have to divide through by a negative 1 or multiply through by negative 1, same result. And I will end up with a 2x minus a 3y. That'll equal negative 5. And there you go. Now we're in standard form. When we're in standard form, finding the slope is easy. We know the slope is the negative of a over b. So the slope in this equation would be 2 over 3. We know the x-intercept very simply. That is found by doing c over a. And let's see, that will end up being c over a. It's not a pretty one, but that's okay. C over a, I lost it, negative 2.5, 0. And then the y-intercept is found by doing c over b. Or, of course, you could plug zeros in for x or y respectively. Okay, and I think I'm going to get 1 2/3, right? Because the two negatives will cancel. All right, now this blue one here is in almost in standard form. I'm going to subtract 4y from both sides. So I'll get 1/2 x minus 4y equals negative 1/3. But I don't have an integer coefficient, so I'm going to multiply through by a number that will get rid of all my fractions. And by now you should be pretty good at this. It'll be 6. And when I do that, I'll get 3x minus 24y. And that'll equal negative 2. All right, if I want to find the slope, you don't always have to, but you can. I believe it's going to be 1/8, right? Okay, the x-intercept will occur at the point 2/3, 0. And then the y-intercept will occur at 0, 1/12. Yeah, kind of a tricky one to graph, but that's what it would be. All right, if you need more help with standard form, let me know. All right, functions. Remember, for something to be a function, oh, this is number 1 and this is number 2, I didn't number. For each input or each member of the domain, there can only be one output. Okay, remember, I think of the input are your x values. It's like people. And then the output are like restaurants. Right? Okay, is it possible for 3 different people to go to the same restaurant? Of course it is. Is it possible for one person to go to the 3 different restaurants at the same time? No, it's not. Okay, so let's take a look at number 1 here. First of all, the domain of this would be 2, 3, and 4. Right? The x values. Okay, the range are the y values, and that would be 5 and 6. Notice I didn't list the 5 twice. All right, is this a function? Well, where's 2 going? Only to 5. Maybe Nick is only going to Burger King. Okay, Melissa is only going to Burger King. And then Sean is going to McDonald's. This is okay. This is a function. If it was not a function, I would call it a relation. All right, number 2. Here I've given you a mapping. There's my domain, negative 3, negative 5, negative 7. I don't know, maybe this is Colin, Madeline, and John. Is it possible that all 3 of them show up at the Olive Garden at the same time? Even they're not going together, no, they just run into each other. Sure it is. Okay, so this is a function. Okay, I'm not going to list the domain and range of this one because there's your domain. You know, it would be -3, -5, -7. Okay, that's your domain. Oops, should put a bracket there. And then the range would just be 4. All right. Number 3, you figure out the domain, you figure out the range, and you see if it's a function or a relation. Hopefully you're ready to see my answer. This is only a relation because the domain is just 2. The range is 12, 13, 14. So this is not a function because that's like Derek trying to go to 3 different restaurants at the same time. He's triple booked. He can't do it. All right, number 4. There's your domain. There's your range. I didn't give you a mapping. Sorry about that. All right, we're going to go like this. We're going to go like that. And we're going to go like that. Hopefully now you realize that this is not a function. It's only a relation because the 7 is going to more than one member of the output. One member of the input is going to only one member of the output. All right, if you graph, make a little sketch graph, y equals 2x plus 1. Would this be a function? Remember the vertical line test? Get a little graph going on here. Up 2 over 1, something like that. And so my line will look something like that. Of course, this is very crude, but we know it's going to be a linear equation. Producing a line. Trying to get an arrowhead on there. All right. Now, if I take a vertical line and I see if the graph intersects it more than one place at one time, and no, it does not. This is a function. The domain would be all real numbers because x could be anything. There's no x value you couldn't put in here. And the range would be all real numbers because there's no y value you couldn't get out. All right. 6, hopefully you know that that's going to be a vertical line. Oops, sorry about that. Let's see here, where'd 6 go? All right, 6 is going to be a vertical line, right? And it would occur at x equals 2, so maybe right here. And of course, I'm drawing this very crudely. I'm in a little bit of a hurry. This would fail the vertical line test, wouldn't it? Because that would intersect the whole line all the way. Okay. The domain would only be 2. The range would be any real number because y could be anything. And so this would only be a relation. All right. Number 7 would be a parabola, right? It's a quadratic. And again, I'll make a real quick graph here. It's going to look like this. Okay, there's my origin. I know the zeros are going to be at +2 and -2. I know the vertex is going to be at 0, -4. And so it's going to go like this. And again, I apologize for the crudeness. Will that pass the vertical line test? Sure it will. Sure it will. Yeah, it won't intersect the vertical line in more than one place. The domain would be all real numbers because x would be anything. The range would be any real number such that y is greater than or equal to -4 because notice the parabola doesn't go below 0, -4. So the range would be any real number such that y is greater than or equal to -4. All right. This one here, this is a weird one to graph for where you're at in Algebra 1. So I'm going to do a little bit of a graph. Okay. Oh, I don't know what that is. All right. And the graph is actually going to look like this. Okay. And there's going to be a negative portion to it here. Okay. This will be a function. It will pass the vertical line test, as you can probably tell. But its domain would not be all real numbers because x could never be 0. So you could never get 0, put a 0 in for x because you're not allowed to divide by 0. It's not a real number. So it's an undefined number, actually. It's not even imaginary. So its domain would be all real numbers such that x does not equal 0. The range would be similar, all real numbers such that y does not equal 0 because it's impossible for this fraction to equal 0. To get 0 in a fraction, you must have a numerator of 0. Like 0 over 9 is 0, right? Well, this numerator is 1. There is no value you could put in for x that would cause the numerator to turn to 0. Okay? All right, that's it for this review video. Mr. Lawrence signing off. Have a good night, everybody.